Okay. Hey everyone. Today I'm going to be talking about scaling iOS developer experience with Tuist. A little bit about me. I'm Vijay, and I've been working with iOS since Objective-C days. I worked in team sizes of a variety, I must say. Like I've been a single engineer at one company, and then I've also worked at companies where mobile teams were like 100 people large. And lately, I've been focusing on improving the developer experience and helping iOS engineers ship efficiently at Carousell. So what makes a good developer experience, right? Let's break down a typical development workflow. It usually consists of onboarding, analyzing, implementing, verifying, and then iterating and then re-verifying. Right? So whenever we want to make a change to a particular part of the code base, this is the loop that we go through. And for the onboarding part, usually familiarity and simplicity is very important. And for the rest of the parts, it's usually strong tooling capabilities, which kind of up the game for the engineer. And these are usually the core pillars that provide a good developer experience. So let me walk you through my journey at Carousell. So I joined Carousell back in 2021, and our iOS code base was mostly one monolithic target and 5 core modules extracted. The build times were unsatisfactory, to put it in a mild way, but still, we were still on our Intel machines back then. However, in the same year, Apple came out with Apple Silicon, so that became available and everyone was excited. And there was discussion in the community that how every other company should just phase away all the Intel machines and bring in the M1 machines so that the productivity problems would be solved. Of course, given the impressive benchmarks, our team also got a M1 for everyone, which was a 16 GB one. And to be fair, we saw a significant jump from the performance when we compared to our older Intel ones. And although this relative performance jump made us happy, in about 1.5 years' time, we realized that the gains had started to wean off. And during the annual developer surveys, our iOS engineers mentioned a consistent theme of increased build time. So we decided to do an in-depth analysis to solve this problem for good. So we ended up doing laptop benchmarks where we took our code base and then benchmarked it across a variety of machines. Something that we noticed was that when it came to CPU performance, our chipsets were still holding up pretty okay. Right? The trend basically showed that on each of the chipsets, there were very similar trends of the CPU just idling for a bit, but then it was not like the CPU was completely occupied at any point in time and was a bottleneck. But when it came to the memory, we realized that the new Xcode that had come out and also our code base, which had grown significantly, had become more demanding in terms of memory requirements. So this observation was even more significant when other applications were run in parallel with Xcode, which is usually what our daily workflow looks like. And to be more specific, our build times would get slower exactly at the point where the usage of memory would enter swap, right? And post that, it would get like deadly slow, and this primarily because swap in and outs are very expensive in nature. So given that we realized that memory was the constraint here, we basically went ahead and gave everyone a 36 GB M3 Pro laptops, right? So whenever we have a problem and we complain to engineering leadership, the first thing that they want to do is like throw money at it and get the problem solved first, right? Because at the end of the day, the reality is that the engineer's time is the most expensive resource in an organization, and you'd rather spend a one-time expense rather than a recurring expense for a period of time. So while this helped us alleviate the issue of slow build times to an extent, little did we know that a new challenge was coming our way. So we embarked on a new project to revamp our design system, and we realized something, that our Android and web platform teams were significantly ahead of iOS, right? And when, in fact, the web team was not even on your laptops. They were using laptops from 2 years ago, and still iOS team was behind them. So something was going wrong. Right? We had a brief chat with engineers from all the platforms, and we tried to analyze their workflows, used to build out these standalone UI components in our design system. So from talking to our Android team, we realized that they use Jetpack Compose Preview as part of their main workflow, and the web team was using hot reloading capabilities in React, which has been since Swift was in infancy, right? So it was a pretty mature technology. So although some of us had tried using Xcode previews, mostly in our side projects, we did realize that to get it to work in our main code base, it would probably take a bit more effort. But then also our design system was kind of modularized already. So we were hoping that it's going to work. So this is how we basically felt about it, that, OK, it's going to work for us, right? But then we had challenges with that. So mainly, we had to support minimum iOS 13, which meant that we couldn't use Swift UI as well. Also, given that we have a lot of UIKit code still lying around, we wanted the previews to be performant with UIKit. Also, a quick debugging made us realize that static libraries did not support previews. And basically, one more point on that. So, which meant that if we wanted to use previews, then we would have to manually go and change the Macro library type from static to dynamic, just use the previews and turn it back into static, right? Because it would not be reasonable to ship these frameworks as dynamic libraries to production just because we wanted to use previews in development. So post this change, we thought that, OK, is previews finally going to work? But then no. We still had a challenge because for us to use previews on a particular part of the code, the dependencies that the code depended on also had to be recompiled. So, and the worst thing about it was that previews and simulators did not share the build cache back then. So for example, if you went and you ran previews on your machine and went to run it on the simulator after that, it would just throw away everything that it built for the previews and rebuild for the simulator. And the next time you switched back to previews, the simulator cache would have been gone. So recent Xcode 16 notes says that some of these issues are fixed, but the reality of it is a little different. So we'll talk about that later. So at the end of it, we just felt that running it on the simulator is a much easier option. So we tried other things. So at this moment, we actually realized that spending more money and getting more powerful machines was no longer a solution. We had very powerful machines, but then it could still not make most of what our code base had to offer at that point in time. So we ended up taking the same path as most companies had, right? Which was a common knowledge by then that modularization was a battle-tested strategy to tackle these build time issues. So although we wanted to embark on this journey, a few concerns held us back. So mainly, it was the risk involved in making such a refactoring across the code base while maintaining production stability. So we could just not assign tasks to ourselves that, hey, OK, we're going to pull out all these modules, and if something went wrong in production, say that, OK, sorry, guys, we can't do anything about it, right? So that was one of the concerns. The second was the effort, right? Given that we are still a significantly small company, the effort of balancing feature delivery along with doing a modularization effort was quite difficult to balance at the end. And lastly, we did not know whether it would be enough, right? Our standalone design system could still not use previews. Then what gave us the guarantee that modularizing a code base could give us the results that we wanted? So this was something we still had to figure out. But in the interest of getting things rolling, we sketched a plan to modularize our code base first. So a rough sketch looked like we just mapped our code base into functional and feature domains. And then simply put, we would start at the bottom, do the core layer first, then the capability layer, after that the feature layers and the application layer, and we would just iterate as time went along. But then when it came to the tooling, we actually had a few options, right? One, we could be completely unreasonable and try to manually manage the Xcode project and XC workspace files for all of the modules using Xcode, or we could use SPM, Tuist, or Bazel. So although we had these tooling options in place, we wanted to align on actual outcomes that we wanted to get out of this exercise before we chose our tooling. So next, the criteria that we wanted to meet, right? But at the end of it, we wanted to also set a goal in terms of what is the developer experience that we want to meet for the iOS team with respect to Android and web. And given that we had reference from those platforms, we knew that we definitely wanted UIKit previews to be working for rapid UI prototyping purposes, and then automatically generated preview apps for UI, API development, and breakpoint support. And lastly, pair this with hot reloading on the simulator. So a bit about preview apps, given that the other two topics are quite familiar for everyone. Preview apps are basically just a wrapping application target for every feature module, right? The advantage of this is that developers get to rapidly iterate on the feature currently being worked on, because we just try to have that feature in isolation and not anything else when it comes to the whole code base. And for both simulators and previews, we could get faster feedback because we're just looking at a scoped amount of code at any point in time. For example, if we look back at our design, so we could actually, okay, yeah, it's available, right? So if you look at the feature module layer here, we could be focusing on just one of those boxes and its dependencies and just forgetting about the rest. So that is where we wanted to get to. So in terms of, yeah, we're here, right? So this is what preview apps are, and it would basically mean that for a post-detailed feature framework, we would also get a post-detailed feature app target. So we knew that to unlock these kind of feedback loops, sub-minute build times were essential. And as we learned from our previous experience, just modularizing a module was not enough. So we recognized that to squeeze it down further, we had to consider more advanced strategies. So this was our chase for the sub-minute build times. So let's have a look at our build graph once again. We see a tree of well-defined nodes with dependencies defined between each of those nodes. So it's time to ask ourselves a few questions, right? Do we really need everything always? Or could we just pick what we needed when we needed it? So this basically meant focused workspaces, where if I'm working on the post list feature, then I basically exclude everything else in the build graph, something like tree shaking. And this would basically help us significantly cut down on the code that we loaded and compiled, which meant that at the end of the day, it would be a top-down optimization, where nodes from the top would be excluded, and less things would get loaded into Xcode, thereby giving us faster and more accurate autocomplete as well. So the outcome of this would basically resemble a bento box, where we would only pick things that we needed, and we create a workspace for ourselves and use that instead of using the whole project, which would be more like a buffet spread. Now, on to the next question. Do we really need to build everything, or could we just pre-build some things and reuse them so that for things that we don't expect to change? This is the principle behind binary caching, where let's look at the build graph once again, right? It consists of internal and external dependencies. So in this graph, you could probably see the shared model framework and the Alamofire framework. So both of these modules, when I'm working with just the post list framework, I would probably not make changes to any of those bottom modules, right? But I still would have to keep them as source files, which doesn't make sense, because if I have to compile them again in my project, it just eats up my bandwidth. So at the end of it, we wanted to freeze them as XV frameworks and just consume them in our project, so that even if I did a clean build and try to build once again, both of the ones at the bottom would never compile. So this kind of an optimization would basically be a bottom-up optimization, where we are trying to eliminate nodes from the bottom and just retain ones at the top. So using a combination of a top-down and bottom-up approach, we could minimize the number of nodes in the build graph that we had to compile, thereby reducing the amount of things that Xcode had to do for us. Also, it's quite commonly known that in SPM, like if any of you are familiar using SPM and you fetch your dependencies, if you see a intermittent issue in your workspace and you do a clean build folder, basically your SPM dependencies are gone, right? So we also didn't want to run into that issue in a new setup. So yeah, no more throwing away SPM caches. So with the plan and strategy out of the way, we wanted to get back to the tooling. With these strategies in mind, we started to evaluate our options. Our considerations mainly were that any inefficiencies of maintaining and resolving merge conflicts in project files was a no-go. So that basically took the manual approach out of the window. And then we wanted to have the ease of use and reduced effort of modularizing and maintaining the modularized structure for a lean team like ours. So we are basically like a 1:10 ratio of platform to product engineers. So we couldn't afford to bring in something that everyone was not willing to maintain. And then we wanted to have something which has a strong generation and customization capabilities that we could build on top of if we had more requirements in future. And lastly, we wanted it to allow the optimizations that I just spoke about to get better return on investment from the effort that we would spend on this. So finally, we ended up going with Tuist, and our reasons primarily were that it's a Swift-based DSL. It would help us decentralize the work of extracting and maintaining these modules, right? Because Swift is something that's, it's probably a first language for most of us in this room here. So the same would apply for my team, and instead of me introducing something like Bazel, which would require Starlark or a variant of Python, like Tuist just felt more first nature. And also it ticked off most boxes when it came to project generation foundations, and things like focused workspaces, binary caching abilities were just available out of the box. And the project, when I had a look at it and researched, it looked like they had a good plan for maintenance, growth, and recently also sustainability. So they also have like a way to make revenue out of the project. So that means that you can be assured that they're going to be working on it for quite a bit. And along with this, it also had low coupling with the code base. So meaning that if tomorrow, for some reason, we felt that we wanted to migrate to Bazel, then it's an easier migration for us to make. For example, if we hired more people into the platform team and we felt that this is a more important issue for us to address, the Tuist integration would not be very closely coupled with our code base for us to spend a lot of time with. So what actually is Tuist, right? At a bare minimum, as I said, it's a Swift-based DSL. But to put it in a more detailed way, it allows us to describe the build graph that I spoke about in terms of Xcode's primitives. And by Xcode's primitives, I mean like projects, workspaces, targets, schemes, etc. in Swift language. So, and based on this, it generates the projects and workspaces for you on demand, and then provides build optimizations based on the above graph that it generates. And everything post-project generation actually remains the same. So there's no change of build system like when it comes to Bazel. So if you run into issues, most probably your issue will be found on Stack Overflow. So you don't have to go hunting elsewhere. And also when it comes to linting, they have codified a lot of configuration rules into the framework. So if you make a mistake while you're trying to write your project description, and you try to generate the project, it will complain and tell that, hey, you know what, you can't be doing this because you can't basically link it in a particular way. So it has a lot of domain knowledge that has been coded into the framework itself. And how does Tuist work? Basically, it only considers two things as the source of truth when creating a module. The first one is the configuration and the paths that's declared in the respective module's manifest file, which is a project.swift file. And then the actual files on the file system on the disk, which are defined at the path inside the manifest above. And based on these two, it then generates a project or a workspace when a Tuist command is run. This is vaguely how it looks like. You have a project file, and then you have files on your file system. So with a combination of those two, it will actually create the workspace and the project file for you. And with this detailed knowledge of the build graph that you provide, it then makes the build optimizations based on the different commands that you run. And some of Tuist principles and the way that it has been built is that at the core, it relies on explicitness, right? It leaves nothing to the build system to assume, which is a good thing, because if you have had experience in the past, you might have seen that when you run something, it works, but then you clear derived data, it stops working, or vice versa. So things could happen that way. And all of this is because the derived data folder basically is more like a global namespace for Xcode. So a lot of things get stored there, and some of them are like transient artifacts, which should not be there when you're probably switching between projects. So a lot of this happens for those reasons. And explicitness in creating the project graph basically means that for every given input, it tries to produce the same output, right, which is hermeticity. And when it comes to the commands, like let's look at a few of them, which you might most commonly use. The first command is Tuist edit. So this one is when you want to open up the configuration files inside your project and just work with the configuration files. And then you have Tuist install, which installs the dependencies. Currently, Tuist supports or natively supports dependencies using SPM or XE frameworks, where SPM is not available. And then you have Tuist generate. This is the one which generates the whole workspace and projects for you based on the manifest that you wrote using Tuist edit. And then you have Tuist generate module name. This is the focused workspace command where you give it a module name, and it uses that module name as reference to do the tree shaking and eliminate all the adjacent nodes. The next one is Tuist cache. This is related to the binary caching abilities that the tool provides. And the last one is Tuist clean. This is more like, I don't know, does pod have a similar command? I think like some of these commands like Tuist install is very very similar to pod install, but I don't know about, I think it should be similar to pod deintegrate, if I remember correctly. An example use case of creating a focused workspace would be, I would do like a Tuist install, which would install all of the third-party dependencies that I have mentioned in my project. And then I would do a Tuist cache so that I can build a cache for all of the nodes, both internal as well as external. And then lastly, I would generate a focused workspace, which is like Tuist generate and a module name. So a lot of theory. So let's move to demo. And yeah, let's see how that goes. Okay, first things first. Let's figure out. Okay, I don't see my terminal. Why? Oh, okay, it's here. Okay. Okay, still working. So far, so good. Okay. So firstly, I will actually walk through the, so many monitors to look at here. I'm a little confused. Okay, I can do that. It's the race against time. So let's see if I can get it done. Okay. There's a Finder window all the way there. Okay, so this is the demo project that I've written. So if you notice, right, there is no project or workspace file within this file system. But all you notice is that there's a Tuist file, there's a workspace file, but this one is more of a definition file. I'll go through that later. You have a folder for app, capability, core, feature, and then one for Tuist. So everything that you see here is mostly configuration files, with the exception of feature folder having exact feature modules with the source code and the resources for it. And then even the core has the respective core. So I've basically tried to replicate the build graph that I showed you earlier as a demo project. So what we'll do here is that we will go ahead and try to look at our configuration files. So as we spoke about it, the command is Tuist edit. So this would launch Xcode for me. Oh, it's here. Yeah. Juggling. Yeah. So if you notice, I need to pick from here. Okay, we have an app. Yeah. So this is how a project.swift file looks. So if you look at it, it's basically Swift code, but it contains references to Xcode's primitives. So you see something like project, target, and then you see info.plist, all of that, right? And at the bottom, I'm mentioning the dependencies that are associated with this target. And also, like if I want to associate some source files and resource files. So there's also support for wildcard path. So you can basically just use globs in that way. So in this file, I've just defined the topmost level node, which is the application node, where I'm defining that, my app is going to be called as Tuist demo, and it's going to have these dependencies, sources, resources, and also a test target. So this is what a simple manifest file looks like. So let me go into one of the more root nodes. So we have a networking module in the application. So I would define the networking module very similarly. It's just that it would have different dependencies and a different name and a different bundle ID and so on and so forth, and also a different test target. So similarly for core modules, you would notice that it's very similar compared to networking. When it comes to the feature module, there is some extra stuff that I've written which might make it look simple. So this code does not need to be here. Let's comment it out. Yeah. So it's as simple as this, but that's because we have written helper functions, which I'll go into a bit later. Apart from this, there is this package.swift file. This is where is very similar. It's actually the SPM file where we declare our third-party dependencies. So it's the same file as that. And then there's a workspace file where at the top level I've defined if I generate a workspace, what are the different projects I want to be associated with that workspace. The Tuist one you can ignore for now is because if this is more to do with the cloud functionalities of Tuist that I'll talk about later. But the rest is okay, some helper functions, extensions, and then this is the one where I've written some code to simplify the creation of a feature framework, where I've said that, hey, okay, if a feature framework wants to define it in this way, then invoke this function, which will create a feature framework and then try to create like a framework target and a test target. I also have given the additional functionality that I can get a framework target, an application target along with it, and then a test target. But basically, these count as a bunch of helper functions to standardize the way that we define things within the build graph. So next, I think we can go to, given that we are slightly clear on the manifest files and how it reflects on to the files on the file system, we'll go ahead and try to generate our project. So where is this? Go and do okay. So first we install the dependencies. Okay, typo. Oh, okay, it's already installed, not bad. Then I'll go ahead and generate the project at its most bare level. So in this project, you'll notice that it has actually created the whole project with all of the nodes, where you have networking, you have the shared model, feature, and the dependencies. And all these dependencies, you'll see that they are source code, right? Okay. Yeah, they're in source code form. So whenever you compile, all of these need to get compiled. So after this, let me actually try to generate a workspace, but something that is more scoped to a particular module, right? Let me do a Tuist generate post detail app. Okay, as usual, Xcode's going to complain, but now you'd see that the main target which was there previously has gone away, right? And you only see post detail and a few more baked in frameworks, but the main one that you see for the application target will be post detail. And let's actually go into the code for post detail, and try to see if we are able to get it to, okay, I don't see sources from here. Okay, we have this particular file, right? So this is, as you see, it's a UIKit class. We'll try to get it to render a preview. Fingers crossed. It should fail. Will it fail? It's taking a long time. So if you actually notice, as it tries to build for previews, there should be a task which is running. Okay, cannot preview. Right? If you look at the reason, it's usually quite mystic, but in this case, you'll see that because it is static, it does not support, right? So looks like Xcode release notes lied to us. So in order to get this to work, traditionally what we would have to do is that if you went into the post detail project and to build settings, you would notice the settings for Mac O, which would say that it's a static library, right? This is the issue that we have, and static libraries are not supporting previews. So what do we do about this? So if I take you back to the manifest files, there is a neat trick that Tuist lets us do, which is in the templates, it has the ability to take in environment variables, resolve them, and then decide what the value should be in the generated project. So in this case, the environment variable would be Tuist underscore is underscore dynamic. So let's try that. Tuist underscore is underscore equals 1. Tuist generate post detail. Okay, So this time around, if we look at the project, let's just inspect it once again. You see that it's become a dynamic library now, right? So let's go to our view controller. And this time around, is it running? I can't see. Oh, it's spinning. Okay. 3, 2. Okay, it's taking a bit of time. Oh, no. This is what I was talking about. The entertainment part. But, okay. You see, this is, so one of the errors that you usually see is that it's going to time out. It takes a very long time, right? This is quite flaky in nature. Like sometimes it could work, sometimes it wouldn't, or sometimes it would just plain error out. So what we'll do is that we will try to build a cache for our code base and try to see if that works. So in this case, it just creates a XE framework for every node in the build graph, so that when we focus on a particular node, all the downstream nodes are XE frameworks, and all the upstream nodes are gone anyway. So, okay. Let's see. It's going to take some time. Okay. Is there anything in the meanwhile that I can demo? Oh, okay, it's still building. I think I should have made a slide, last one, saying, this is why you should not do live demos, right? I think it's going to take a bit of time. So in any case, things that we want to see working right now is like previews, show up, and then preview apps, and then hopefully hot reloading. Okay, I think it looks like it's ready. So post detail app, I have everything that I need. Okay, there's my cursor. Okay, that time, lucky. Oh, I have 59 seconds left. This is, yeah. So to quickly go through it, let me just make sure that it's working in nature and not just a trick. So okay, what is this? It's an image, Let me take the title label, try to set it to 100, right? So it just changed instantaneously. So the next thing that we can do is that, okay, let's just look at the time that it took as well. So it took about like 14.4 seconds, right? Now, if you compare this with the whole of your application, it's a minuscule, basically. So ideally, you would want to get this kind of an experience at a feature module level so that you can iterate really fast at a feature module level, and then you do a final integration test with the whole application. So next, we will try to run the same on the simulator. And this trick, I hopefully will work. Okay, can I get an extension of 2 minutes? Just want to run it. Okay. 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 It's running. Yeah. So as you see, the preview app basically launches the features first screen by default, right? So the advantage of this is that imagine that you have a complex application where you want to make a change in a particular feature deep down in the navigation stack. So every time you make a change to that feature, it's not just the build time, but it's also that as an engineer, you need to launch the app, navigate into all of these flows, go into that screen and say that, hey, okay, now it works. So this kind of an approach kind of skips all of that hoops and takes you directly to the feature screen. And the last bit that I wanted to show is how it also supports hot reloading. Okay, let's go back to post. Oh, okay, yep. Yeah. So let me turn this back to. So if you see, this is actually not the preview, it is the simulator, right? But still using the framework that Christoph has written called Inject, we can enable it by default on any preview app that is generated for a feature module. So you can get instantaneous feedback even at a simulator level, thereby allowing you to use this for UI, API, as well as breakpoint support. Yep, I think that's mostly it. Yeah, I think that should be for the demo. I think I can just go to the last slide, close it out. Some benchmarks that we've seen, early benchmarks, is our full project basically took like about 200 odd seconds as a baseline. The Tuist generated version took slightly lesser, but that was mostly because we could drop a few files as we cleaned up the project. But the one with binary cache basically went down to like 163 seconds, which was like about 23% faster. This is because we binary cached all of our third-party dependencies, meaning that we didn't have to compile them at all. And these are clean build times. But the more interesting numbers are at the feature module level, where a Tuist generated project is basically, it only took 58 seconds for a clean build, and it took like, with binary cache, it took about 17 seconds. So theoretically, your incremental build times as you iterate on a feature should be much shorter than that. Yep. So as I said, the benefit observed were that we got like free preview apps for every feature module that our engineer creates, and it basically makes us more efficient, and also the autocomplete is better. Couple of other things that we automated, but I think, yes, we have run out of time. Oh, okay, cool. All right, so just a few other things that we have extended based on this at Carousell is that we have standardized the module creation. So we have written a few scripts with that, basically like one-liner commands. You just run a command, it will do the bit of setting up the folders and the files in the file system, and also create the project.swift. So the engineer doesn't have to do anything from their end apart from filling in the manifest, and it creates like about an experience of under 10 seconds, and it's foolproof because it's standardized. So this is the approach that we have taken in order to modularize at Carousell. And then few other things that Tuist does, because it's evolved as a tool after we adopted it, is that they do Tuist caching on the CI. So if you're interested in that, what they do is that they allow you to do distributed caching. So it builds on one of the laptop machines or on the CI, and you can store it on the cloud. Then all of your developers as well as the CI jobs can use the same artifacts and cut down on the compilation time. So you save on your CI costs as well. And then it also seems to have selective testing ability now, where if in your whole code base you just modify a particular module, then it only runs the tests for that module and the modules that depend on it, but not anything else, right? So that way, instead of running like probably like 1,000 tests, you run much lesser number of tests without risking any kind of production stability. And lastly, I think this is something new that they have released, where it allows you to generate shareable links for the apps that you build on the CI, and it'll just post it on your PR. So the person who's reviewing the PR can just directly scan the QR code, get the build, and then test it out, whatever the changes are. Yep. And finally, some closing thoughts. This is from myself personally, is that all of us feel that we would want to work in a job where, and a workplace where we feel productive, acknowledged, and appreciated. But when it comes to our workplace setups, with the code bases and everything, we don't seem to have the same expectations for some reason, right? But why not is the question. So I hope that my sharing probably will reduce the homework for some of the people here, and they can try solving these problems at their companies as well. And if there are more things that you would like to discuss, then yeah, please do reach out at the break. Yeah, any questions? That's it.